All right, last example in our quadratic function review. We have a quadratic function, and we know we have a quadratic because the highest power on the x is 2. But we have a quadratic function in standard form. Standard form, remember, is when you have a function ax squared plus bx plus c, which is what we're used to when we're thinking quadratic formula. Okay, so finding our vertex. In vertex form, you can quickly pull out the vertex of the function. That's why it's called vertex form. When it's in standard form, you have a little bit more work to do. So we have a formula that h is equal to negative b all over 2a. In our function that was given, a is 4, b is 8, and c is negative 5. You keep the sign with it. So here, when we're plugging in for h, we're going to have the opposite of b, so the opposite of 8, all over 2 times a, which was 4. Watch how you plug this into your calculator. If you wind up getting negative 16, it's because you multiplied by 4 instead of dividing by 4. And we find out that h is equal to negative 1. To find our k, we need to take our h value, which is the x-coordinate of our vertex, and plug it into our function. So we're going to plug in every time we see an x, we're going to plug in negative 1. So we're going to have 4 times negative 1 squared plus 8 times negative 1 minus 5. You can plug this into your calculator all at once if you would like. Just watch your parentheses because of the negative. If you would like to work it out by hand, you can. We would have 4 times 1 minus 8, because 8 times negative 1 is negative 8, minus 5, which gives us 4 minus 8 minus 5, because the 4 times 1, which gets us to negative 9. So we just found out that k is negative 9. Remember, our vertex is in the form h comma k, which means that our vertex is negative 1 comma negative 9. If we found our vertex, we found the axis of symmetry. Remember, axis of symmetry is in the form x equal to h. It is our vertical line through the vertex. So we're going to have x equal to negative 1, because that was our h coordinate or the x coordinate of the vertex. Domain, we have a quadratic function. And as soon as you have a quadratic, our domain is immediately all real numbers, negative infinity, positive infinity. This is because we can plug in anything we want into our function and we won't have an issue. And you're like, what kind of issues could you have? Well, if you try to divide by 0, check in your calculator, take any number you want, divide by 0. Your calculator will freak out. That would be an issue. If you try to take the square root of a negative, remember that gets us into imaginaries. We don't want to do that. That's why we say all real numbers. If you try to take the square root, like I said, of a negative and you have a square root in your function, there's some issues there. You can't plug everything you want in. And then when we get to them, logs are going to do some of the same thing. Okay, but here, parabolas are our friends. Domain, all real numbers, negative infinity, positive infinity. Our graph opening up or down. Remember, that's all dependent upon A, our leading coefficient. We said A was 4, which is positive. And remember, when you are positive, you are happy, your mouth is smiling, corners go up, so we open up. If our graph is opening up, we know our vertex is our turning point, which means it's down here. And if it's down there, that means our vertex is a minimum. Oh, my apologies. Technical. Okay. Next part, we need to determine the range and where we're increasing and decreasing. So we know that our graph is opening up. I'm going to give us another little visual here. We had our vertex, -1, -9. So if I am looking for my range, we have a minimum. So that's our base. And then we're going up. We're going up towards positive infinity. And our bottom piece, our minimum value is -9. So my range is -9 to infinity. Because remember, I don't care about the x values when I'm talking about the range. I only care about y values. So now that I have found my range, I'm going to go back and look at my graph to find where I am increasing and decreasing. Then put my vertex back in. Remember, when we're dealing with increasing and decreasing, we don't care about the y values. We only care about the x values. So I'm going to ignore the y. We know on the left, we have -infinity x values, negative x values. On the right, we have positive. And we know that our graph has our axis of symmetry going straight through. Let me move my infinities down just a little bit. There we go. So now we need to follow along on our graph, going from left to right. And you can trace it with your pencil and see what happens. So going from left to right, we're going down, which means that we are decreasing. So we are decreasing on the first half, and then we hit our turning point and we go up, which means that we are increasing, which means that we are increasing on the second half. The interval for where we are decreasing, we have from -infinity to -1, and then we stop. And then for increasing, it was on the right half, so it starts at -1 and goes to infinity. Remember that we have parentheses around everything because -1 can't make up its mind whether it's increasing or decreasing, and infinities we will never reach. So they always get parentheses. I'm going to scroll up for a second because our next one, our x-intercepts, I need to remember what our function is. Remember, h of x is the same thing as f of x. It's just a different name for the function. It's like if you have multiple kids, you're not going to name them all Fred. You're going to give them different names. So example number 2 had f of x. Example number 3 has h of x. We have 4x squared plus 8x minus 5. And we're going to set it equal to 0 to find the x-intercepts. You have a couple of different options. You could use a quadratic formula if you would like, because quadratic formula will always work. and we have a quadratic, degree 2, or the highest exponent is 2, which means you can plug into the quadratic formula. If you have imaginaries, irrationals, so not nice whole numbers, or whole numbers, quadratic formula will always work. But because I know some of you need to review your factoring, I'm going to walk you through how to do this one with factoring. Factoring won't always work, but in this one it does. We already said that A was 4, B was 8, and C was -5. So we need a product, a multiplication of 4 times -5, which is -20. And we need a sum of B, which is 8. So remember A times C and the sum of B. Okay. So now you need to go through, bugger, I keep having technical difficulties. All right, there we go. We need to find two numbers that multiply to be -20 and add to be 8. So if I just start writing numbers down to try to figure it out, I know that 4 and -5 multiply to be -20. But when I add them together, I get -1. That's not the 8 that I wanted. So I could keep going. What else goes into 20? Let's see. I could do 10 and -2. And that gives me 8 because 10 plus -2 is 8. Because I found my magic numbers, I'm done with this part and I can go into my factors. I apologize for continuing to jump. So from here, because my 10 was positive, I'm going to have x plus 10. My 2 was negative, so x minus 2. We need to divide by a, which was 4. Simplify your fractions. So x plus 5/2, x minus 1/2. And then bottoms up or slide, divide, slide tells you to bring them back up. So this factors into 2x plus 5 times 2x minus 1. Remember, we still had our equation equal to 0. From here, take each one, set it equal to 0. Each of the factors, I mean. Here you would have 2x is equal to -5. So x is equal to -5/2. And the other one, we would have 2x is equal to 1, and x is equal to 1/2. Do not try to combine these together. It's individual ordered pairs. Our first one is -5/2, comma 0. And our second is 1/2, comma 0. And that would be the same thing that you got if you use the quadratic formula. Last one, we need to find the y-intercept. Remember, to find the y-intercept, you plug in x equal to 0 into your function. So we're looking at h of 0 is equal to 4 times 0 squared plus 8 times 0 minus 5. I always like finding the y-intercept when it's in standard form because everything cancels out except the very end, the constant term without a variable. Because 0 squared is 0 times 4, still 0. 8 times 0, 0. Don't care about it. So we get -5. This tells us that y equal -5 is our y-intercept, but we want it as an ordered pair. Remember, we plugged in 0 for x, so 0 is going to come first, and then our -5. comes second. So our ordered pair is 0, -5.